Welcome to the 7th lecture on computational mathematics with Sage Math. In this lecture we are going to look at using while loop in Python. While loop is used to repeat a block of code multiple times until certain condition is met. So we need to give the conditions, and as long as that it is one condition or several conditions are satisfied, you need to execute a block of codes. If you recall, the for loop, actually it was used to iterate over elements of a list or a tuple. It could be a set or dictionary, and that is why in Python for loops are also known as iterators. The for loop is more appropriate when we know number of iterations in advance, whereas in many cases the number of iterations which is required in order to execute a particular task is not known, and in that case we can use while loop. Right. So the while loop is preferred where the number of iterations is not specified. Of course, in case of for loop we saw that in case the number of iteration is not known, we can break the iteration once certain condition is satisfied. Okay, so now let us look at how to use while loop. So generic syntax for while loop is given by this: while, you can write inside the bracket or without bracket, one condition or more than one conditions, and then you execute statement 1, statement 2 and so on. So this is the block of codes that will get executed as long as this condition is satisfied. Okay, let us look at a very simple example. Suppose we want to print 1 to 10 using while loop. So how we are going to do? So we will say while I is less than equal to 10, print I and increment I by 1, and you need to also initialize I equal to 1. So how will this loop run? So first it will check I, since I is equal to 1, which is less than equal to 10, it will go to the next. That means it will print 1, and then I will become I plus 1. I plus equal to 1 is same as I is equal to I plus 1, right? Now I will become 2, and then since 2 is less than equal to 10, it will print 2, and then now I will become 3 and so on. So as long as I is less than equal to 10, it will print. The moment I becomes more than 10, that is 11, then this loop will stop. Okay, so let us execute this, and you can see here you will get 1 to up to 10. In case we want to have more conditions, then we can put more conditions combined by or and. So that we will see it later. Okay. Now let us look at an example. The example is to find the number of years an investment of 20,000 becomes double using compound interest at the interest at 5% calculated annually. So this we have seen using for loop, and in this case we used actually break statement when the investment became double. But the natural thing is to use while loop. And how do we use while loop? So first you define the principal amount, that is 20,000, interest rate 5%, and you calculate the amount using this formula. This we have done many times earlier, and as long as this amount is less than 2 times the principal, you run this, and of course after you find the amount, you print the amount in those number of years. And since we are applying condition on amount, this amount has to be initialized. So we have initialized amount to be the principal value. It will work for any initial value as long as it is less than 2 times the principal. Okay. and of course you need to increment the number of years. So, let us run this, and when you run this you will get after 1 year amount after 1 year, I think there is spelling mistake in the amount after 1 year is 21,000, after 2 years is 22,050, and so on. After 15 years amount becomes 41,000, which is just more than double of the 20,000, and therefore it has come out of this loop. Okay. So, in this case you see that we do not know how many years it is going to require in order to get to become the investment double, and that is why we are using for loop while loop. Okay. So, in case for example, if I reduce the interest rate, for example, let me make it 4.5% and run this. In this case the number of years required is 16 years, whereas in case of 5% it was 15 years. Okay. Let us look at another example. The next example is to find GCD of two integers a and b. Now, finding GCD stands for greatest common divisor. So, if you have two integers, find all the divisors of a and b, positive divisors actually, and find the one which is the greatest among the two divisors, the divisors of a and divisors of b. That is what is called greatest common divisor. Now, in case one of them, let us say a is 0 and b is non-zero, then the greatest common divisor will be b, and in case b is 0, a is non-zero, greatest common divisor will be a, and in case both are 0, a and b both are 0, then any integer divides 0, and therefore there will not be any greatest common divisor. So, you can say that greatest common divisor does not exist in this case. And there are different ways of finding greatest common divisor. One can list all the divisors, or you can use division algorithm. That means, let us assume that a is greater than b, then you divide a by b, and in case the remainder is 0, b is the greatest common divisor, provided b is positive. Okay. So, first of all we will use that the greatest common divisor of a and b is same as greatest common divisor of mod of a and mod of b. So, it is better you can take a and b to be positive. In case they are negative, you can convert into its modulus. Okay. So, in case b does not divide a, you will get remainder, and then suppose the remainder is r, then next time you divide b by r, and then look at in case the remainder is 0, the GCD will become r, and you continue this process until the remainder becomes 0. That is one algorithm to find GCD of two integers. This is known as division algorithm. So, let us see how we can make use of division algorithm in order to write program for finding GCD. Okay. So, this is how we can write. So, first we have say, let us say a is 24 and b is let us say 66, and so a and b will take the value of absolute value of a and absolute value of b, because it is possible that one of them is negative or both of them are negative. So, for example, let us say b is minus 66, convert a and b to absolute value. In case a is 0, then check whether b is 0. If b is 0, then a and b both are 0. In that case, the GCD does not exist. In case b is non-zero, then GCD is b. Similarly, if a is non-zero, then check b. If b is 0, then GCD will be a. Otherwise, that means both a and b are non-zero. In that case, we will first check whether a is bigger than b. In case a is less than b, you interchange a and b and then apply division algorithm. So, division algorithm is divide a by b, and in case the remainder is 0, you find out the remainder, that is a by b, and store that in b, and then a will take value of b. Okay. And then once the remainder is 0, then it will come out of this loop, and then you print what is the last value, that is the last value here is the b, and that is b is non-zero, and since a and b both are positive, you will get the GCD. So, let us execute this. So, in this case the GCD of 24 and 60 minus 66 is 6. For example, if I put b equal to 0, GCD will become 24. If I put a and b both 0, GCD will not exist. If I have a is equal to 0 and b is equal to, let us say, minus 7, then GCD will become 7. Now, suppose we want to define user defined function for GCD. We have already seen there is a user defined function, there is a function to find GCD in math module, but suppose we want to create our own user defined function. Let me call this as my GCD. So, then in that case, if you input a and b, two integers a and b, then it should give me the output. So, in this case, what you can do is you can simply copy paste this inside the body of the function, and then of course, you need to indent it, and then instead of print GCD, I will say return GCD. Okay, so let us see. Yeah, so this is, I have called this as my GCD a and b, and if you noticed, I have simply copied this particular code from the above syntax and put it here, and at the end I am just saying return GCD. Let us run this, and suppose we call this function my GCD of 204 and minus 176, it is, and the answer is 4. Suppose this is 0, then it should give me 204. If both are 0, it will say GCD doesn't exist. Okay. So, this is how you can make use of this division algorithm to find GCD, and we have created user defined function for the same. Okay. Let us look at another example. The example is how many tosses are required to get 6s on both the faces if two 6-faced dice are tossed together. So, if you are tossing two dice together and on both you want 6, so how many times you need to toss in order to get 1? But of course, you can see that this will vary. Sometimes it may require, maybe you can get both the 6s in first toss itself, or you may not get after so many tosses also. Now, in order to do this problem, so tossing, we will just generate a random number between 1 and 6, and that random number can be thought of as outcome on the face of a dice when it is tossed. Okay. So, let us see, there is a function called sample inside random module. So, if I for example, if I say import sample from random module, and then if I use sample range 1 to 7, that means 1 2 3 4 5 up to 6, and this is the how many you want out of this numbers. That is, if I want to toss, if I want to find out 3 of them, if I want to take a sample of 3 from 1 to 6, you will get here, you will get it will be here 3. So, you will get a list of 3 numbers, random numbers. If I do once more, I will get another 3 numbers. If I want to generate only 1, then I will put here 1, but in this case you can see here it generates a list, but what I want is a number. So, I will take the first element of that is 0th index, and that you will get this. So, now we will make use of this in order to find how many tosses are required in order to get both 6s. So, we can iterate, we can use again for while loop, and when we use while loop, so first we need to initialize the number of tosses, which is equal to, let us say, 0, and we generate 2 numbers n1 and n2, which is the sample from 1 to 7 1 sample, and 0th element, that is take the number we have done already here. So, this will generate n1 and n2, and then find s to be n1 plus n2. Now, in case s both are 6, n1 and n2 both are 6, the sum will become 12. So, in case sum is equal to 12, you need to come out of this loop, and otherwise you need to run this again. So, as long as s is not equal to 12, you continue this process, and that is why s has to be initialized. You can initialize anything less than 12, but I have initialized it equal to 2, which is the minimum value that you can get when you toss two dice together. Okay, so let us run this, So, when you run this first time 56 tosses are required. Let us say if I run once more, this time 47 tosses are required. If I run once more 22, if I run once more it is 118. So, of course, it will vary, the number of tosses is not same because it is a random. Okay. So, this is a simple game that can be generated using this. Now, let us look at another example. So, for example, all of you must have seen this series summation 1 upon n factorial, n going from 0 to infinity. This actually converges to an Euler number which is E, which is denoted by E, and its value is 2.718 something. So, we want to find the value of this Euler number within certain range, that is which is correct up to certain number of decimal places. So, if you see here, this we can't find infinite sum. So, in this case what we will do is we will define what is called partial sums Sn, and this is a sequence actually. So, Sn converges to E as n goes to infinity. So, that is what you have. So, and also it is increasing sequence, and if you look at Sn and Sn plus 1, the Sn plus 1 will have much better approximation than Sn, and if I look at Sn plus 1 minus Sn, that is the error term you can think of, and that error term once it is less than 10 power minus 4, you can stop this. So, let us see how we can make use of. So, first of all, let us find out what is the value of exponential 1, that is Euler number, and since we are going to make use of factorial, so that also we know that it exists in math module. So, we will import both exponential and factorial function, and the value of exponential of 1, that is Euler number, is 2.7182818284 ... This is up to certain number of decimal places. Now, let us use while loop. So, this error, this is the error term we are thinking. So, in this error, if it is less than 10 power minus 4, we have to stop. So, we initialize the error as 1, and the tolerance we have 10 to power minus 4. So, let me change this to 10 power minus 4, and the value, that is value is the approximate value of exponential of 1. So, that again is initialized as 1, right. So, now initialize as 1, which is nothing but 0 factorial, 1 upon 0 factorial. So, while error is bigger than the tolerance, you find out the 1 upon n factorial, which is actually the error actually the error is 1 n plus 1 factorial, and since we have starting at n equal to 1, and then yeah. So, no, first this is will be error is equal to this, and so increase the E value by the error. So, first time 1 factorial, 1 upon 1 factorial is 1, we started with 1. So, this will become 2. So, now this error is less than it is greater than equal to tolerance. So, again it will go to this place and run. Of course, you need to increment n by 1, and let us say evaluate this. So, if I evaluate this after 9 terms, we have got this correct up to 4 decimal places. If I change this to let us say 10, and then the number of terms which are required is more. So, this is 15 in this case. If I change it to let us say 20, then it will require more number of iterates, which are required 23. So, of course, in this case the convergence is quite fast, and that is what we can see. Let us look at another example. So, this example, in this example now we will make use of break and continue with while loop. We have seen in the last lecture we can make use of break and continue for along with for loop. So, break, what does it do? It breaks the loop at intermediate stage in case certain condition is satisfied, and continue, what does it do? It skips that particular iteration, execution of that particular iteration. So, we can make use of break and for break and continue using along with while loop as well. So, let us take a simple example. In this example, actually we want to write a Python code to find the sum of positive integers starting from 1 which are not divisible by 2 and 3 both, and stop this when the sum becomes more than 1000. So, let us see how do we make use of this. So, we will start with I equal to 0, the sum is equal to 0, and while true. So this is actually infinite loop while true. Okay, so while true, so you increment I by 1, since I equal to 0, this will become I equal to 1, and check whether it is divisible by 2 or divisible by 3. In case it is divisible by any one of these 2 or 3, then you skip, because you want something which is not divisible. So you skip that, that is use continue, and then otherwise you add I to S. I was 0 initially, sorry, S was 0 initially, so S will become S plus 1 in the first case, and in case this S is more than 1000, then you break. So in this particular code we are making use of both continue as well as break. So let us run this. So when we run this, and let us now print what should be the number of integers I, so that from 1 to I, the sum of all these integers which are not divisible by 2 and 3 becomes more than 1000. So that is 77. If I instead of 1000, if I want, let us say 2000, then you will require more iterations, more number of integers, in this case 109. Okay, right. Okay, now we can also make use of what is known as else with along with any loop, for loop and while loop inside Python. So that's a very nice actually a feature. Many times when none of the condition inside for loop or while loop are satisfied, then you can make use of else, then you display some condition. So what does it say? In case you use for loop else with for loop, then it is going to then it execute so when the for loop finishes iteration. So if all the iteration is over, and then only this will get executed. Similarly, in case of while loop, if you use else with while loop, then it gets executed when the condition becomes false. If all the conditions inside the while loop are false, then it will execute. Okay. So let us use this. So for example, in this case, let us look at an example of finding prime between two integers. In case there is no prime, then you print that the prime does not exist between two integers a and b. So we will make use of is prime function, which we created in the last lecture, and now so what do? We have a is equal to 200, b is equal to, let us say, 210, and for k between a and b included, check whether that number k is prime. In case it is a prime, then you print it is a prime number and you break. Otherwise, if you cannot find prime, then you use else and then print that there is no prime between a and b. So if I execute this, it says that the prime between 200 and 210 doesn't exist. That means every number between 200 and 210 are composite number. Suppose if I, instead of 210, if I make 211, then 211 is actually a prime number. Okay, right. And suppose you want to increase that length, instead of 210 we want to make it 100. So between two consecutive 100 integers, if there is no prime, you want to find such a range. Okay, right. So let us see. So the way we are going to do is, we start with, let us say, we want 100. So let us say we want we know that there are many primes between 1 and 100. So 100 is not going to work. So let us try with 1000. Sorry. So between 1 and 1000, is there some range? Let us say k and k plus 100, such that there are no primes between these two. Okay, so how do we do that? So we will use nested for loop. So first, this is the loop, which is just very similar to what we have here. In this case, instead of a and b, we are using I and I plus 100. Okay, I plus 101. So both 100 is included, the range is included. Okay, and in then you do from 1 to 1000, 1 to 1000. So it will start with 1000, and then see. If this doesn't happen, if it is unable to find any interval of of length 100, that is consecutive 100 integers which does not have prime number, then it will say that is 1000 is not enough, you give a larger range. So, let us run this. So, it says that you choose a larger range. Now, instead of 10,000, let us make it to the power 4, that is 10,000. Still it is unable to find. Let us make it to the power 5, and then it takes little while, and it is still not able to find. Let us make it 6. It should be able to find in this case, but it will take more time to run because there are so many iterations it has to run. Okay. Of course, you can make this procedure faster. It is still running. So, yes, now it has found. So, you can it has found that 3,70,262 and 3,70,363, 262 and 363. Between this range, you cannot find any prime. Okay. Of course, if we want the length not the 100 but 1000, then it will require even larger range. Okay. Similarly, you can make use of else with while loop also. Suppose you want to toss a 6-faced dice 6 times, and in case you get 6, you say you win, otherwise you lose. So, that is a very simple thing. So, how we have made use of else here? So, you started with initially the toss is equal to 1, and in case this toss is less than equal to 6, keep on tossing, and in case the face value is equal to 6, then you print you win and break, otherwise you increment I by 1, and in case it is unable to find within this 6 tosses any 6, then you say you lose. So, okay, again we are making use of sample function, taking one sample from 1 to 6. Yeah, so you win. If I say again time, you lose. If I run again, you win. Again you win. So, what it says is most likely when you toss 6 times, one of the thing you will get as 6. Let us look at one last example of finding a root using Newton-Raphson method. I am sure this you must have already seen. So, if you have a function f x equal to 0 and you want to find a root of this, that means find a value of x such that f x equal to 0, one can use what is known as Newton-Raphson method. So, you start with some initial guess value x naught. Of course, you need to know the convergence criteria for this. Not every initial guess, not every function will have convergence, but at present I am not telling you what should be the convergence criteria and all that. I hope you already know it. So, this is the Newton-Raphson scheme. You start with x0 and then define x1 xn plus 1, that is, so n equal to 0. So, now it will become xn plus 1 is x1 is x0 minus f at x0 divided by f dash at x0. Of course, you need the function to be differentiable, and the next time you once you get x1, you find out x2 and so on. So, let us make use of this iteration scheme for f x equal to x square minus 3x plus e to the power minus 2x, and in this case let us make use of while loop, and in this we do not want to do too many iterations. So, maximum 20 iterations, or if the value of the function becomes less than 10 to the power minus 5, this is in absolute value because the function value can be negative. So, in absolute value if it is less than 10 to the power minus 5, you stop. So, how do we do this? So, let us write a user defined function for this. So, the name I am giving is Newton-Raphson, and you input f, you need f(x) df, that is derivative of f, initial guess, maximum number of iteration as I said 20, and the tolerance which is the 10 to the power minus 5 in this case, right. So, you once you have entered this, define f naught to be f at x naught, iteration number is 0, and apply while loop. So, while the absolute value of f x is bigger than tolerance, because we want, in case the tolerance is f x k is less than 10 power minus 5 k, then you stop. Therefore, this has to run as long as the value of the function in absolute value is bigger than tolerance, and the number of iteration is less than equal to 20. So, if both these conditions are satisfied, then it has to run. If any one of these is false, that means if this value becomes less than the tolerance, or this value becomes, the iteration becomes more than 20, then you stop. And then what you do, you define x 1 to be x 0 minus f at x naught divided by df at x naught, and then f x 0 you initialize, again you value of x 1 you put it in x 0, f at x naught you recalculate and increase the iteration number. And at the end I am just saying that in case the iteration, the number of iteration is less than the maximum IT, then it has converged. If that does not happen, then it has not converged. So, this is going to be true in case the convergence is obtained within 20 iterates, and false otherwise. So, and it returns the value x naught, that is the xn plus 1, and then true or false depending upon whether it converges or not, and then in case it converges, the number of iterations. Okay. So, let us run this, and next let us call this function. So, I am calling this function. So, let us first define this function. We are defining this function using not def, but using lambda. So, this is another convenient way of defining a function quickly. So, this is f is equal to lambda, f is the name of the function, and this is the argument, and the output that is returned is 2 to the x to the power 2 minus 2x plus exponential of minus 2x, and that is why we are importing exponential. And similarly, you define derivative of the function in df, again using lambda function, and then call this function NewtonRaphson f df, and initial guess, let us say I make initial guess is equal to 10, and the tolerance limit, as I have said, this is equal to 5, this is equal to 5, and then let us print in case it converges. If converged, that means if it is true value, then you print that the Newton methods have converged and with so many iterations, and also print the what is the solution you have got. Otherwise, you print that it has not converged. Okay. So, let us run this. When you run this, it says that this has converged in 6 iteration. If I increase this, let us say if I make it 15, then it has converged in 6, and if I make it, let us say the initial guess very far, let us say 1000, then it has required 14 iterations. If I, instead of, let us say if I make it 25, then it says that it has not converged. That means in case of this is very small tolerance limit, it will require more than 20 iterates. Okay. So, let me write here 5 and maybe here 100. So, it has converged. Okay. So, these are the examples using while loop. Now, you should also look at in Python, you also have a notion of pass along with loops. You can also look at how to make use of try and except, and since when we have created this user defined function, we mostly give the fixed number of parameters. Of course, some of them are default parameter, for example, in this case maximum, IT and tolerance, but in case you do not know how many parameters user is going to supply, then you can make use of what is known as star args and double star k w args. These two are very convenient way to make the function flexible. Star args passes a variable number of non-keyworded arguments. So, it will be non-keyworded argument, and okay, and then you can apply operations on all these keywords, and similarly, but double star kw args, here args and kw args you can replace it by some other thing also, and in this case this is actually a keyworded argument, something very similar to dictionary. Okay. So, try to explore these options, they are very useful, and it makes functions flexible. Okay. So, at the end, let me leave you with few exercises. These are simple exercises. The first exercise is write a Python program to find the value of golden ratio. correct up to 5 decimal places using while loop. So, I have already defined what is golden ratio in the previous lecture, and second exercise is to write a Python program to find the number of digits and also the sum of digits of any integer n. Okay. So, n could be any integer, could be small, very large, and the third one is a function f(x) has a 0 in an interval a b if the product of f a and f b is less than 0. That means the value of the function at a and b are of opposite sign. And so, what we want to do, we want look at this function f(x), it is the same function for which we wrote Newton-Raphson method, and we know that it has a 0. So, find an interval of length 1 which contains 0 of this function. That is the third exercise. So, these are the 3 exercises. Of course, we will be posting the solution of these exercises after some time, but you should try. These are all very simple exercises. Okay. So, let me finish here. So, thank you very much. We will see you in the next lecture.